test for symmetry. X-axis, I replace y with minus y in the equation. If an equivalent equation results, the graph of the equation is symmetric with respect to the x-axis. And when I look at that, this is what it says. And I can't remember those words. Words just drive me nuts. That says, if I have, and I draw myself a little axis, if I have a coordinate point, x comma y, if I'm symmetric with respect to the x-axis, it would come down, go through the x-axis. The point I'm interested in would be the opposite of x and y. And that's my replacement. My replacement would be the opposite of x and y. Because it's got a fold on top of each other here when I fold it across the x-axis. And then it says y-axis. Y-axis, replace x by minus x in the equation. If an equivalent equation results, the graph of the equation is symmetric with respect to the y-axis. It said replace x by minus x. Now, to me, these are just words. So I come back over here and I say I want y-axis. That means I'm going to go this direction. And if this is x comma y, my replacement is going to be, I can see, the opposite of x, y. So if I had 3 comma 2, it would be minus 3, 2. And that would be true for any coordinate point. You give me a coordinate point on the graph, I just change the x values, it gives me the coordinate point on his symmetric piece.
Yeah, the first one has to be negative 1.
Oh, it has to be negative y. Oh, thank you. Now, if I can remember how to make iMovie work, I could actually redo this problem by myself and edit it in, and you'd never see the error, but unfortunately. Origin, replace x by minus x, y by minus y. If equivalent equation results, the graph is symmetric with respect to the origin. So again, I have my axis. I draw my picture. This is x, y. I go through the origin, and his symmetric mate is minus x minus y. That's going to be my replacement. So this says, how do I test? Now this is an example of how you test. If I have an equation, and here's the guy right here, and I want to test for symmetry, I would, for x-axis says x stays the same, y changes. So if I would replace y by minus y, x stays the same. If this is symmetric with respect to the x-axis, then the two equations, this would remain the same. That says I've put a coordinate point in that makes the equation true. True means the two sides are identical. And not, because this is not same, this is same. And if it's not same or same, then I know it's not the same. And if it's not the same, it's not symmetric with respect to the x-axis. With respect to the y-axis, now here I am again. I take this thing, go across. It says x changes, y stays the same. And that's what I did. I left y alone. I changed x. The question is, do I get the same equation? Well, the opposite of x squared is just x squared minus 9. The opposite of x squared is just x squared plus 2. What do I notice? This is the same as the original. that is the same as the original. Same means same. So this is symmetric with respect to the y-axis. So I look for and then if origin again, I pick a point, image it through the origin that says I change both x and y. I changed y, I changed x. Here I get that minus y equals x squared minus 9 over x squared plus 2. What do I notice? Not, right? And what about this two sides? Same. Not same means it is not symmetric with respect to the origin.